Welcome to the ISO Show, dispelling myths and sharing tips for success to improve your business with ISO standards.
If you're listening to this podcast, then you're in great company. We've got thousands of listeners who have a thirst for continual improvement and raising standards in business. Whether your interest is in quality, sustainability, or risk standards, I'd love to welcome you as a member to our online platform for all things ISO, the ISology Hub. The ISology Hub is the leading place to get access to all of your online resources, from in-depth training courses through to our very popular coffee break training, to templates and action plans and many other resources to help raise standards. As a member, you get access to over 100 courses, taking you from learner to practitioner to leader. The ISology Hub has all the resources that you need, which will really help to make your life easier and to help improve compliance in those business critical areas. So if you'd like access to learning and compliance resources ranging from data privacy to environmental management, anti-bribery, business continuity, quality, health and safety, to name just but a few, the list is endless actually, then we'd love for you to come and join us. Just head over to the isologyhub.com.
Hi everybody, welcome to another ISO show. I'm Ian Battersby, your host. I'm one of the senior consultants at Blackmores UK Limited. We've been running this for some years now and hopefully you're finding it interesting, covering topics that should be of interest to people who are working in standards and management systems. Today I want to talk about finding cause. What I'm not going to do is try to explain the many detailed techniques for doing root cause analysis. There are too many. There are too many intricacies and complexities. I couldn't do them justice at all. I need many hours and some very nice PowerPoints even to try and even get started. I'm going to give you an overview of some of the most common techniques, but not in great detail. What I want to do is discuss why finding cause is important, what the standards say about them, and also one of my favourite topics is why integrating findings from different sources can be really quite helpful. Firstly, I want to talk about generally about terminology in the standards. There are different words used when things don't go to plan or when you need to do something about that sort of thing. Firstly, in the management systems standards, if the output from a process is not what you expect it to be, i.e. it's a non-conformity, we're required to make corrections. Okay. Now, when making corrections, we're not required to find cause. This is about putting right what went wrong. So imagine an example where we've delivered a damaged product to a customer. It's about swapping that product for the perfect one if they're not happy. If we discover during a production process that there's a wrong dimension on one of our pieces, can we alter that dimension to make it correct? Okay, this is what we do before we do anything else. But this is purely reactive. It doesn't help us to find out why the product was damaged or why it was the wrong size in the first place. Okay, so for that, we need to find the cause of the problem and apply what's called a corrective action. This term is really quite important. Some of you might be wondering about preventive action, or preventative action as some people call it. The term preventive action is no longer used as a formal requirement in management system standards. Since the current style, the high-level structure of management system standards was introduced in 2015, preventive action has been replaced by a broader concept of risk-based thinking. The concept of preventive action was, I think, widely misunderstood and very badly applied. I also think that it was an obstacle to getting people engaged in understanding why things go wrong, getting people who don't have a quality management head, a management systems head, people who aren't trained in root cause analysis, using some terminology put them off, didn't get them engaged in doing the right thing. Also, I think that terminology has been an obstacle to proactive risk management. And that's what the standards are about now. Put simply, when designing your management system, you must try to plan for the things which may go wrong by assessing the risk to your management system. And as 9001 puts it in clause 6.1.1, when planning for the quality management system, the organisation shall consider the context of the organisation, the world in which you work, your interested parties, we all remember those, and determine the risks and opportunities that need to be addressed. And they need to be addressed for different reasons. Firstly, to give assurance that the management system can achieve what it's supposed to achieve, its intended results. Secondly, to enhance desirable effects, so make things better, give you better outcomes. But importantly for us, in what we're talking about today, it's also to prevent or reduce undesired effects. So things going wrong, non-conformity, that sort of thing. And on the back of that, achieve an improvement in your system. So in planning your management system, you should already understand your context. This is right at the start of the standard in clause 4. The context is the world in which you operate, your customers, and it's about your own strengths and weaknesses. And you need to plan your system according to that world and according to those strengths and weaknesses. One of the things you should understand in contemplating your strengths and weaknesses is whether your processes are good at delivering what you want, are outcomes that you get the intended outcome. Now, there's no longer a need for preventive action because you should be reviewing your risks continually based on your experiences of non-conformity and of how well your processes are delivering. You should be reviewing those outcomes, analysing trends, improving your system continually. And that is what the standard's built up to make you do. And by the way, if you have a log of non-conformities or of improvements, a continual improvement log, that sort of thing, try to avoid using the term preventive in that these days, because that word doesn't really feature anymore. And also, if an auditor asks you about preventive action, gently remind them that they're 10 years out of date, because it still does seem to happen. And take them to your risk register instead, and point out that your risk register is there to identify proactively the risks your system faces and what you will do to prevent those risks actually occurring. So what does or do all of the standards say about finding cause? Because they all mention the same things. The bulk of it in all of them's in clause 10 on improvement. They all say words to this effect. The organisation shall determine and select opportunities for improvement and implement any necessary actions. Those actions are there to meet requirements of customers or whatever it might be. Now, necessary actions. You don't have to take actions over everything, right? At this point in the standard, it doesn't even call them corrective actions. It just calls them the necessary actions to meet your requirements. And it talks about choosing, determine and select opportunities for improvement. These opportunities shall include improving products and services, importantly for us, correcting, preventing or reducing undesired effects. So that is basically the things which can go wrong. And then from that, improving the performance and effectiveness of the system. It then goes on to talk about non-conformity and corrective action. Non-conformity basically is anything which has had an unexpected outcome. So when that unexpected outcome occurs, you should react to the non-conformity and, As applicable, these words are important. As necessary, needed, applicable, they're always important. Take action to control and correct it. So we've talked about correction and deal with the consequences of that correction. So immediately put right what's gone wrong and deal with whatever it is at that point in time that needs to be dealt with. And then you need to evaluate the need for action to eliminate the cause. Don't do everything in all circumstances. Evaluate what you need to do next, okay? In order that it doesn't recur, and also, very importantly, that it doesn't occur somewhere else in your organisation. You're not just interested in it not happening in that instance. You want that lesson to be learned throughout the organisation. And what you have to do there is review and analyse that non-conformity. So carefully look at what happened and determine the causes of that non-conformity, right? And if similar non-conformities exist or could exist potentially, deal with them, right? So implement any actions if they are needed. Not always, there are always actions which are needed. Also, you've got to review whether those actions you've taken are actually effective. And the standard very explicitly says, update the risks and opportunities that you determined earlier in the planning phase and make changes to your management system based on that. So this cycle removes that need and that mention of preventive action. It's about planning and changing where necessary. But you're steered towards risks throughout this. One thing you've got to remember as well is that, and the standard is explicit in this, corrective actions need to be appropriate to the effects of the non-conformity encountered. So it's important that you don't apply unnecessary resource to putting in place lots of corrective actions if those corrective actions do not make changes which are commensurate with what the risk was in the first place. So keep that in mind when you are bending over backwards to investigate what's gone wrong. What was actually important in this circumstance? Now, I mentioned one of my pet projects most of the time is this concept of integrating issues from different sources. I've talked at length in podcasts before in the ISO show. I've talked with clients and colleagues, and I've talked throughout my career in different organisations about integrating issues from many different sources in order to help to find cause. We did ISO show number 185 last year, in fact, in August of last year, which covered this very topic. So I would point people towards going to listen to that one if you get an opportunity. And I won't repeat everything from that. But I'll just reiterate why I feel that it's important to take this broad view when you're trying to establish cause. This is all about finding cause, okay? Without removing cause when something has gone wrong, repetition may occur. As I've just described when talking about the clauses of the standard which talk about finding cause, it's about recurrence and avoidance of that. It's about finding whether it could occur elsewhere in your organisation. So it's important to pull in as much information as possible to do that. And this is where integrating improvement data from multiple sources really does come into its own. The idea of common cause, as I like to call it. A single cause could manifest itself in many very different outcomes in an organisation. If we take an example of a worker who lacks competence in doing a particular activity, okay? They could, by their lack of competence, be involved in a process which is then delivered wrongly, okay? Hence, there is an adverse quality outcome from that process. A process or a product non-conformity could lead to. It could end up with the customer. The product could arrive with a customer. The customer could receive it. The non-conformity could be apparent to them, and they could raise a complaint. Okay? Like the damaged product I just described, which needs a correction. If the product isn't spotted until after it has been delivered and put into service, something could go wrong there, which could cause, a warranty claim. If it's in service and causes some damage or harm or loss to the customer, you may be in the realm of a claim for damages. Okay? The same competence issue could manifest itself in an accident occurring which harms the worker. Okay? That's a different type of scenario. It's a different standard to 9001. We're in the realms of 45,001 there. But there's still the same cause from that. You could already be in the realms of there being an environmental issue because you may have had to scrap or rework something which causes greater waste. Okay? You could be in the situation where you've led to an environmental incident, such as a machine discharging something it shouldn't because it's being used wrong. These two examples of harm to an individual or harm to the environment could lead us into a regulatory breach or even enforcement by one of the authorities, an environmental or health and safety authority. Because some of these outcomes may not be apparent until they've impacted on the customer or other interested parties, they may not be recorded internally through a non-conformity system, so they may not be investigated in the same manner as a product non-conformity. So, you see, to get to root cause, you may start from very different starting points, depending on where it's manifested. Accident, environmental incident, complaint, claim, product non-conformity. So, having a common methodology for establishing cause across all types of these should help to make life easier. And also, if you've developed skills by identifying cause in one part of your organisation, then consider extending that skill to all parts. Now that takes us on to techniques, really. There are many. They are varied. Some complex, some simple. Not all techniques lend themselves to all situations, so it's worth mentioning some of the more well-known ones and where they might be best applied. As I said already, I won't go into great detail. In situations where some of the more technical, complex ones are applied, there ought to be people trained in their use. There'll be safety critical rules in some industries which require competence in these methods, which I don't possess. I can only just give an overview as to what these things are. I haven't been involved in all techniques in root cause analysis. I've been involved in some. So I've got a few of the more well-known, more commonplace, more popular ones, ranging from quite simplistic through to quite technical. The first one is 5 whys. I think most people have heard of the 5 whys. You repeatedly ask the question of a scenario, why did that happen? Usually 5 times, but there is no hard and fast rule on how many it could be. You might arrive at a root cause after 3 whys. You might think after 5 I need 1 or 2 more. There is no rule on this. It's simple and it's fast, and it doesn't really require much training. It just needs openness to answering the questions really honestly and probing beyond your initial understanding. It can be used by non-technical people. It can be used by frontline teams involved in management systems or the technical aspects of non-conformity and the like. And when things are quite straightforward, it comes into its own. It's good for quick fixes. It can be used very quickly. You can find things out very quickly. And it's sometimes used as an early problem-solving technique before you get into more detailed analysis. Okay? Before you get into deep analysis on the technicalities of a job, where there may be more data, there may be systems, there may be production processes which need more in-depth examination. Then there's the fishbone diagram, or the Ishikawa. I quite like this one in many ways. It's a visual depiction of what's happened. A diagram which categorises the possible causes. It categorises them by different groups. I'll talk in a few minutes about what those groupings are. It encourages teams with different perspectives to be able to throw in ideas, brainstorm it basically. And it can help pull out complex problems into what they're contributing factors were, not just a single contributing underlying cause, but the multiple causes which sometimes contribute to a failure. And by using categories, it lends itself to future analysis. So if you have a continual improvement log where you can categorize root cause into different topics, it helps you when you analyze to be able to show where in your organization you feel the issues are. Failure mode and effect analysis is another form, FMEA. This is a more structured technique. It's a sort of risk assessment, but almost in reverse. It looks at what can go wrong and what the effect of that failure is, and then how critical that failure is to the outcome of what you're trying to do. It uses sort of risk priorities to decide on what's more important. It's used when you are designing processes and systems in that planning phase, and it's aimed at planning to remove the causes of failure during the development phase. And a lot of safety critical systems use FMEA to determine what controls are needed. Fault tree analysis is another one. I like fault tree analysis. It's this top-down approach that uses logic. It's a diagrammatic representation of what's gone wrong, which basically says, does this happen? Yes, no. There's if, then, but, yeah, that sort of thing. Very structured, and it allows quantitative approaches. So you can come up with numbers to determine how likely events will be. It's used in engineering processes, manufacturing, and again, it's used in safety critical systems. There are other things which are not necessarily used for determining cause, but they're used as tools in support of that. Pareto analysis is one, the 80-20 rule. This is where you've got good data from potentially high volume non-conformities. And what you do is you can use it to focus on the more frequent or more impactful causes, and you visualize what happens using those causes against the frequency with which they occur. Again, the data-rich environments are good for this sort of thing, and high volumes lend themselves to Pareto analysis. You've got other things like cause and effect matrices, which link processes to inputs to outputs, and it weighs up how critical an input is on what the outcome is going to be. And they're good for process improvement. Okay? Scatter diagrams, we will all have seen scatter diagrams. These are correlation analyses. These visualize the relationship between two different variables. At the moment, or until the last few days, it may be the number of people who've got sunburn versus the number of hours of sunshine there have been. And there are all sorts of correlation analysis which are published in press articles quite regularly. These are the basis for statistical process control techniques sometimes. Again, these are from data-rich environments. But these are where relationships are unclear until you plot on the scatter diagram and the correlation analysis what you found from the data. There are loads of other ways of examining the cause of what's gone wrong in organisations. I'll just talk about a couple of things. Firstly, 5 whys. This is straightforward. Like I said, it requires little training. It requires people to just be open and honest in asking a question and answering it. An example. Let's go through a short 5 whys. A worker is using a saw to cut through a piece of wood. Okay? They've cut themselves with the saw while cutting that piece of wood. So why did that person cut themselves? The worker's hand slipped and came into contact with the blade. Okay, question number 2. Why did the worker's hand slip? They were holding the material in one hand and cutting with the other without any form of steadying or clamping device. Well, why was the material being held by hand instead of clamped? Well, because there was no clamping device on that workstation. Okay, so why is there no clamping device on that workstation? Because the design of the workstation didn't take into account the fact that it needed permanent clamping fixtures on it. Okay, why was that? Because the risk assessment for the work activity at that workstation overlooked handheld operation of a saw for that particular operation. Okay, so we've got down to five whys. So we've got some causes here. We've got workplace design. We've got a risk assessment not foreseeing the workplace activity. Okay? We've also got a worker potentially doing something that the risk assessment hasn't foreseen, because if the risk assessment says to him, you should be safe doing this in this situation, he should be raising his good hand, and saying, yes, I don't think I should be doing this because I haven't got a clamping device. So there are a number of causes in this which can be elicited really quite simply by a very simple tool that requires no training. The Ishikawa fishbone, 6Ms as it has been called in the past, is another technique that can be used. The 6Ms gives you a clue as to where we're going with this. It was initially introduced into production environments and has been adapted into service and other sorts of environments since. Some people have a success version of it. But it initially came out of the 6Ms being the way it's categorized. Okay? It's categorized as machine, method, material, measurement, mother nature, and man. Now, that's a P now. So it's five M's and a P, because a P should be people. And this is machine. So the equipment or the technology you're using. The method, the process, the procedures you're going through. The material, so the raw material, the inputs to that process. The measurement, so the data which has come from that job or the inspection system that's overseen it and measured it. Mother nature, environment, so the conditions in which you're operating, and people, any human-related causes. Okay? So if you look at machine, you're looking at examples of causes such as worn-out tools, faulty tools, poor maintenance, that sort of thing. Methods could be poor process procedure, poor instructions, work instructions, guidance, lack of standardization and approach. Material could be the purchase of defective materials, a variability of materials, the wrong specification of material, that sort of thing. So you see the sort of idea behind this. You can categorize the causes and then ultimately analyze what those causes are when you've got multiple different failures. Now, it takes all sorts of people. Like I said, you could use broad teams with the Ishikawa, the fishbone, to bring in their own perspective on why things may have failed. It's a very good approach. Now, there are these known methods. There are these, if you want, more famous ways of doing it, documented, described ways of doing it. But there's another way. I'm not sure it's got a name, but I've talked quite recently about it, and the risk of citing a previous ISO show again, we did one earlier this year, show number 221, where I discussed processes as a tool for simplicity and improvement. If we look at the standards in the round, they require us to document our processes, basically to write down, in one form or another, how we do what we do. By doing this, we have a description of how we're supposed to deliver our activities, okay? Not always perfectly. This is where we're going with this. As with many elements of the standard, there's no specific method for documenting processes. So you could have process maps, process flows. You could have just written procedural documents. There are different ways. There are instructions, there are drawings, there are all sorts of ways that you can actually define a process for your organisation. And everybody does it differently depending on the circumstance. So there is no one way to do it. Regardless of this, the fact that they're documented in one way or another is extremely useful when we have outcomes which were not intended. Okay? And outcomes which were not intended can be defined as non-conformities. Now, a very simple technique in determining cause, and one which needs no training, is to walk through a process comparing the documented steps to the outcomes that we expected, okay? Where the outcomes have deviated from that expectation provides the point at which a process has failed. At that point, we can ask why it failed, right? Was it down to decision making, authority, supporting documents such as forms, records, any tools we should have used, whether they are electronic or physical, systems, data. We can challenge all aspects at the point of a failure to find out why it happened. Okay? We can use more structured techniques at that point to do it. We could do a 5 whys on that. We could do all sorts on the point of failure. But it's a very good way of finding out where the failure actually occurred. So if we're at a step in a process, for instance, was it missed? If a step was missed, why? If a form wasn't completed, for instance, why? If a correct authorization wasn't sought or granted, why? If an instruction was wrong, why? If a record wasn't kept, why? If data was wrong, why? So all these things could be questioned around any point in a process step where we've seen that something has gone wrong. It doesn't need a specialist, an expert. It needs the people involved, the proper documentation of the approach, and an open mind, a questioning mind to honestly answer, did this occur as it should have occurred? Now, you can use that point to understand the corrective action, which needs to be applied at that point. You've asked all these questions. You've found the position where it's failed. You've asked why it failed at that point. You can then look at the corrective action. Do we need a better form? Do we need to stop on a process at this point where it can't go on unless that form is complete? Are our instructions written correctly? Is the level of authority at this point in a job correct? Are the tools correct? If we're analysing data at this point, why is the data incorrect and what do we do about putting right that data? There's also another way of using documented information. There are all sorts of ways of using a documentation as a tool to try to find cause. For example, in the event of an accident, a risk assessment can be a really useful tool in finding cause. Risk assessments are a great example of documented information which is required as evidence of operational control in standards. In the event of something going wrong, we can assess the effectiveness of that control according to how it's been documented. So comparing again what has happened to what we have written down should happen. So the first thing we can examine is whether a worker has even seen and understood the risk assessment. And if not, this is our first point of failure. Control is clearly not effective if the person affected by it hasn't been communicated with. So that's a simple failure to be identified from a risk assessment. But then looking into the assessment in more detail, the risk assessment identifies hazards and the controls needed to minimise the risk to that worker. If a risk assessment follows a sort of traditional job safety analysis type model, it will include the steps to performing a job and the control measures which are required. Now, in the same way as I've just described for process failures, the risk assessment can then be followed as a prompt to investigation. We can go step by step through the risk assessment and we can find the point where the outcome was not what we expected. And there we can challenge why that happened and put in place measures to prevent recurrence. So, in some circumstances, finding cause maybe through a very targeted technique devised or adapted for your own industry or activities, maybe even be prescribed within your industry as something which is required. In others, it requires little training, as long as we can compare outcomes to expectations in a structured manner. And that's the key, I think. So, to summarise what I've been saying, really, management system standards require us to understand our context and assess the risks associated with that. And we should plan accordingly with a risk-based approach. We should plan to minimise risk using processes, and we should document how we do things. And where we find the outcome of a process is not what we expected, we should determine why. Find the cause. And precisely because we've documented how we do things, we can use a structured approach to comparing the outcome to the expectation. Our corrective actions should address that variation. but we shouldn't apply too many corrective actions or too much corrective action unless it's deemed necessary by our investigation. We should, from that, plan to improve, right? And check that that improvement is effective, and we should then feed that back into our context and risk documents. Our system should improve in response to an understanding of cause and a putting in place corrective actions against those causes. And that is how our management system works. So hopefully, by finding cause, we have a virtuous management system. So I'll leave you with that. Hopefully that makes sense without going into far too much detail on individual types, techniques for root cause analysis. So thank you for listening. Before I go, can I just remind everybody to subscribe to the ISO show on your preferred media player if you've not already done so. If you have just a few minutes to spare, please leave a nice review for us. 5 stars would be lovely. It does help us to reach a wider audience at that review process. As always, if you've got any questions about today's or any other show, please let us know. And we are always looking out for future topics. So feel free to send us an email or just comment on whichever media player you're on. We'd love to hear from you because what you're interested in is what we ought to do. So that's all from me today. Thanks for listening again, and we'll catch up with you on the next ISO show. Goodbye.
Looking to use ISO standards to drive better business practice? Contact us at blackmoresuk.com to access further information and book your free 15-minute call.